Hi everyone, this is CH Rajyalakshmi, Department of CSE, BVRIT, Narsapur. Today I am going to discuss about Schema Refinement and Normalization topic under Database Management System subject. So what are the topics we are discussing in this subject? The first one is Introduction to Schema Refinement, Problems caused by redundancy, Decomposition, Problems related to decomposition, reasoning about functional dependency sets, first, second, third, fourth BCNF normal forms, lossless joint decomposition, dependency preserving decomposition techniques. These are the things we are discussing regarding schema refinement and normalization concept. First of all, what is meant by schema refinement? Where we are using this topic and what is the purpose of the schema refinement approach. Normally, during database design approach, if any mistake done by the database designer, that design can be refined in various levels. So, those levels defined with support of our concept that is called the schema refinement and normalization concept. In the case of software development life cycle, the first phase is requirement analysis, second one is conceptual design, third one is logical database design, fourth one is refinement schema, fifth one is physical analysis, last one is application and security design. So, among these, the refinement of schema play a major role. Why means, if any problem occurred during logical database design that can be identified with support of refinement of the schema. The purification of the structure of the database defined by the schema refinement approach. What are the problems caused by redundancy? Most of the databases suffering with redundancy problem. What is meant by redundancy? Redundancy nothing but the same information repeatedly placed within the same database. The same data repeatedly placed multiple times in a single database. That is nothing but redundancy. During redundancy thing, what are the problems we are getting? So, we are getting insertion anomaly, update anomaly, delete anomaly. So, redundant storage means same thing repeatedly placed multiple times. Why this happening? Why this situation is getting? In the normal scenarios, first of all, if you want to maintain any classroom database, the classroom database consists of student roll number, student name, student address, year of the student, branch of the student. Suppose in a classroom, 72 students are there. 72 times the same CSE, same year repeating. This is nothing but redundancy. The same content repeatedly placed multiple times. According to that way, if you are updating some data, the remaining unnecessary information can also be updating. Suppose if you want insert in some situation, student ID, student name, course ID, course name will be there. Suppose in that organization, the course ID not yet introduced, okay, and as well as students can also students are also not to join in that organization at that moment. So in that case, there is no problem occurred. But where problem occurred, suppose you can see the student database, student ID, student name, course ID, course name. In that, student ID, course ID, make it as a primary key. The primary key attribute properties are what? It does not allow any duplicate values. It does not allow any null values. Suppose in that organization, during 2024-25 academic year, suppose new course joined in that organization. cybersecurity domain course introduced. So at that moment, there is no student in the database. Without student details, we cannot insert entire row in a database. That is nothing but insertion anomaly. Update anomaly is nothing but what? Suppose if any student change the address of that particular student. Suppose if you refer the student set address equal to Hyderabad, where city equal to Narsapur. Suppose in that 10 members comes under Narsapur location. Those 10 members details updated to the Hyderabad. Why means this is a problem occurred because of the redundancy property. Suppose if any student transferred from one institute to the other institute. In such a case, we want delete that particular student detail from the existing database. Suppose that student consists of cybersecurity domain. Suppose that person details deleted from the existing database, only one student joined, those details automatically deleted. At the same time, the course details can also be deleted. That is nothing but delete anomaly. Unnecessarily, some other wanted information can also be deleted. These are the problems occurred because of the redundancy of the database schema refinement. And according to this database schema structures, what type of schema we want to give to the client. That is the main motto of this total topic. So according to this one, first, if you want give the correct schema of any database, so we have to be identify what is the dependency or association exist among the attributes that play a major role for the identification of the association among the attributes. The association among the attributes are the perfect. In such a case, we can give very good database design to the industries. So first of all, what is meant by functional dependency sets? Functional dependencies. Functional dependency nothing but a relationship that exists when one attribute uniquely identifies value of other attribute. Every determinant determines uniquely identifies the dependent value. That is called the functional dependency set. See here, suppose student. Student is the relation name. In this, student ID, student name, these two are the attributes. How can we say this is functional dependency exist? Let R be a relation. That relation consists of x comma y are the attributes. If x determines y, y is functionally dependent on x. This association is called as a functional dependency set. In this, x is called as a determinant. Y is called as a dependent. Y always depends upon x. See here, the same scenario you can apply for the student database. Student consists of roll number, that is called student ID, student name. The student ID always determines student name. Why? Because in a classroom, more than one student may have common name, but every student uniquely identified by their roll number. That's why SID is called as a determinant. This determinant determines the S name of that particular student. Every determinant pointing single value of the dependent. This association is called as a functional dependency sets. Suppose if you are framing any database designing approaches, the attribute association exists, this type of dependencies. Those are called as a good database design approaches. The normalization concept, schema refinement concept, mainly concentrating on giving good database designing approaches to the industries. As per the client requirement, the attribute association play a major role. According to that attribute association, we are giving good database design to the industries. Coming to the next one. If you want, identifies the association, that association exists with support of some rules. Those rules are called as a inference rules. The attribute association defined with support of these rules. The first one is the reflexive rule. What is the meaning of the reflexive rule? Suppose R is one relation, that means one table, that consists of x comma y are the attributes. If x determines y, x is a, that means if x determines y, so y is dependent on x. This is called the reflexive rule. So as per the description, A, B, C, D, E are the attributes. Okay. Y equal to A comma B comma C. That means A, B, C attributes are the subset of x. If x determines y means y is the subset of x. This rule is called as a reflexive rule. Y is dependent on x. Coming to the next one, augmentation rule. The augmentation rule says that partial dependency sets. That means if one attribute, coming to this partial dependency set, I can say student ID, student department ID. Okay, determines student name. That means see this association. Every student name depends upon student ID, not depends upon department ID. This means 50% of the attribute association exists among these two. The remaining attribute not associated. This is called the partial dependency set. The dependent partially depends upon the determinant attribute. The augmentation is called as a partial dependency set. If x determines y, then xz determines yz. This property is called as a augmentation. Coming to the next one, transitivity. This is the third rule. What is the importance of the transitivity? Suppose R is one relation. That relation consists of x comma y comma z are the attributes. If x determines y, y determines z, then x determines z. If any attribute satisfies this type of association, this association is called as a transitivity. The transitivity rule says that whatever attributes association exist, those are the transitive. X determines y, y determines z, and x determines z. Coming to the union rule. Union rule is nothing but if x determines y and x determines z, then x determines yz. This is the union rule. Coming to the decomposition. Suppose if x determines yz, we can also decompose this relation into x determines y and x determines z. This is the decomposition technique. And pseudo-transitivity and one more property is there. If x determines y, xz determines w, then xz determines w. Why? Because some situations for the attribute association point of view, we can add additional attribute also. That attribute also play a major role for the association among the attributes for the refinement of the schema. These are the inference rules for finding of the functional dependency sets. See here how to define functional dependency sets. So, if a given functional dependency sets, whether those attributes, how many number of attributes are closer to each other, that can be defined with functional dependency closures. So, see here, first add A to the set S. Add all the attributes. which are derived from A to the set S. So according to the example, I will explain. Add all the attributes which are functionally determined by the attribute set of S. Okay. This process recursively repeating multiple times to find the closures of that particular attribute. This concept is called as a attribute closures that can be denoted with A plus. Attribute closures defined by the A plus. Okay. Coming to the next one. See, first I am giving one example for the finding of the attribute closures. See here, relation A comma B comma C comma D are the attributes. 4 attributes we are using for the relation capital R. In that, what are the functional dependency sets are there? A determines B, B determines D, D determines C. Find the closures of A. How many number of attributes are very close to the A that we have to be find out by using this example. See here, the first one is S equal to A. That means this is called self-determination. Self-determination. Okay, that attribute itself determines. And given functional dependency, A determines B. So that we have to be give S equal to A determines B. If any association exists B with some other attribute in the given FD is right, B determines D also. So S equal to A, B, D. From given FD, B determines D. Right? And is there any association exist along with DS? In the given FDs, D determines C. So you can give D determines C. So A, B, D, C, right? So the closure of A will interrelated with A, B, D, C. So this is nothing but A closures. Coming to the B closures, if you want to find out B closures, how can we find? We will take B determines D. First, the self-determination. Coming to the next one, B determines D. Yes. So, if D determines any attribute, yes, D determines C. So, B determines D, D determines C. S equal to B, D, C. B closures are B, D, C. But actually, our relation consists of A, B, C, D. These are the attributes. One attribute missed, that means A not close to the B. So that B closures are only B, D, C, not close to the A. Okay. Which attribute close to each and every attribute in a given relation? That is called candidate key. This is called candidate key. A is called as a candidate key. A is closely relevant to all the attributes in a given relation. So that A is called as a candidate key in the given relation. Okay. Suppose these are the association exist among the attributes. Coming to the next property, decomposition. Some situations, very lengthy databases we are creating. So, some situations, the meaningful information we will insert. Some situations, meaningless information can also be incorporating in the existing database. So, those problems overcome, they introduced one more new topic that is called the decomposition. Decomposition properties are what? Lossless decomposition, dependency preservation, lack of data redundancy. Before going to discuss all these properties, first of all, what is meant by decomposition? Decomposition nothing but dividing large tables into smaller tables or dividing large databases into small databases. According to that decomposition, we have to satisfy these properties. lossless. That means after division of your original database into smaller database, we cannot lose any information. That is called the lossless decomposition. What is meant by dependency preservation? So, whatever tables we decomposed, all are interrelated with each other with support of one common column. Then only those decompositions are the legal decompositions. Coming to the next one, lack of data redundancy. Redundancy, if redundancy will be there, that we have to be reduced. These are the three properties of decomposition techniques. So see here, one of the example I am taking for the decomposition technique. Employee department, in this I have considered EID, name, age, city, salary, department ID, EID, department name, make it as a only one table. Okay, suppose I want to insert only department details. At the same time, I want to insert employee also. Suppose some situations I want to insert employee details, I need not want enter department details. At that time, also we have to insert both tables. Why? Employee ID is department ID, make it as a primary key. The primary key does not allow duplicate, does not allow null values. So instead of that situation, we have to be divide our original employee department database into two sub databases. The first one is employee, second one is the department. If you want to incorporate department details, we can directly go to the department. If you want to insert new employee in the organization, we can directly go to the employee database. Suppose if these two decomposed relations are the lossless or not. Yes. Employee and department we can join. Definitely we will get employee department database with reference of common column, that is called EID. So employee department natural join with EID column name. We can combine these two. Definitely we will get employee department database. Right? This is the lossless decomposition. It also satisfies the dependency preservation. All the properties are satisfied. This is the perfect decomposed table. Okay, these are the topics today we have discussed. So thank you all.
Like, share and subscribe. Hit the bell icon for more updates.